The directions are, where are the directions? Determine where any discontinuities will occur in the graph of each rational function. So what does x have to equal 0? 3.5.
So in order to figure out where those are, you just hit the bottom equals 0?
Yeah. Okay, yes. Yes. Okay, so for number 2, I had 2x plus 3. I was able to factor them. Where will the discontinuities exist? Well, when x is equal to a negative 4 or plus 4. Okay? For number 3, it is going to be when I factored them, I could see that I couldn't cancel anything out with my numerator, so it's going to be at x plus 3, x minus 1. Stephen, yes, no?
I got minus 2.
Well, when you factored the factors of 3, that will give me a negative 2. Did you factor it correctly?
Try plugging it in.
Okay. Number 4, I had x minus 5. So where it would be at, in this case, there are 2 places. It could be at x is 5. What happens if x is 0? So is it going to be 0 times whatever quantity? Will it equal 0 then? Yes? Okay, so if x equals 0, 0 times this quantity would make it a 0. So it could be at either one of those. Okay, that was number 4. Number 5, what do I have here? When I factored it, I had 2x plus 3, x minus 7. So the discontinuities were at x equals 7, x equals a negative 3/2. Okay? Do you want me, and I'll give you the last
I
one.
actually got those right.
Okay. And the last one, I had x was 0, x was equal to a plus 5, and x was equal to 2. Negative 2, sorry.
It could also be a 0. Oh,
Right.
Yeah.
I have that. Okay? Everybody okay with that? I mean, is the idea pretty reasonable? Okay, we're just, think about the big picture. I'm just looking for where it's going to be a 0. Now, why is x equal to 1 no longer an option? Why is there just a hole? Why do we downplay it a little bit? Because they cancel each other out. So if I'm left with this, is x equal to negative 1 a big deal? No. If I can factor it out, is it going, x equals a positive 1. If I can factor that out, is that an issue when I simplify it? No. Okay, that's why it's there. If I don't factor it out, that's why there's a hole. And that's why you need to be smart and not necessarily depend on your calculator to tell you, where are the discontinuities? Okay? All right, so in these, I plugged in some numbers. I knew what was going to happen at x equals 2. And so I knew that. So I knew that that was where I would have an asymptote, and I just plugged in some values just to see what I would get. Okay? And let me see. What happens here on number 8? Number 8 had what in it?
A hole.
Had a hole in it. Okay? And the hole is at when x is equal to what? 3? And so there are, in this particular one, there was no vertical asymptote. This one just had a hole in it. So, can you have just an asymptote? Yeah. If I just gave you this one, didn't we just have an asymptote? Okay. In this one, we could have an asymptote and a hole. And in this one, we just had a hole. And it was because we were able to factor and cancel. Okay? All right. So for number 9, there was a hole at 3.
How do you determine if it's an asymptote or a hole?
Somebody help them out.
Whole is when it has the same on the top and the bottom and you have to cancel them out, and the asymptote is what's left over on the bottom.
Okay?
It's the other way around.
No, when you have a factor in the numerator and the denominator.
Oh, whatever would be plugged in there, that's the.
Yeah. Okay? And then in this case, look at that one. Okay? And in this case, I had x's at a -3. And x was at a 1. Okay? So, can you use your calculator? Absolutely. But you need to know what you're looking at. You know, remember, a calculator is only as smart as the person that's using it. So you need to know what you're looking for and what you're looking at. Okay? All right, do you feel a little bit better about that today after having gone over that? I mean, it's not a big deal, it's just an idea. All right. So I have some notes that I would really like you to take today, so please make sure I have some note paper.
How much space do you need for these?
Not much.
Like 1 page.
Okay. So before you put this into your notes, I want you to solve this problem. How would you go about solving this problem? 1/3 x plus 1/4 x is equal to 12. Stephen?
I was going to say find a common denominator.
And the common denominator would be 12. So what would you do to 1/3?
You would make it 4 twelfths.
What?
4
4/12
twelfths.
x plus.
And 3 twelfths.
Yeah, and then
The other side would have to be multiplied by 12 as well, right? Because you'd have to multiply by.
what?
Oh, no, never mind, that, I can do it a different way.
Okay, I want to make sure you understand this, because again, we're working with fractions.
8.
There are many ways, oh, stop that. They're logical, they're very logical. So I know why Cassie wanted to multiply
Well, I was,
that by 12. Do we need to multiply the other side by 12, or by anything?
no, I was gonna do it a different.
Okay, good. Well, I want you to hold your thought, because we're going to solve it the other way as well. So if everybody clear that the least common denominator is going to be 12, so now I have what? 4/12 x plus 3/12 x is equal to 12, and blah, blah, blah. I can continue that way. Okay. Cassie, do you want to just share how
Well,
you were thinking of doing
It's
it?
kind of a longer way of going about it, but I would have gotten rid of the fraction, so multiplied everything by 3.
By 3?
So you have,
Hold on a second. You would multiply everything by 3.
and then, once you have that, multiply everything by 4. Or you can multiply everything by 12.
Okay, you're going to multiply everything by 12. Well, let's see what happens. So I'm going to have 12x over 3 plus 12x over 4 is equal to 12 times 12. And what is the beauty here?
No fractions.
No fractions.
See,
I
think
skipped
about
a
it.
step?
Well, no, from the top one. The top one will be minus that middle step in there.
Okay, so is everybody comfortable with this idea? If I have two numbers that I know are equal to each other, if I multiply one side and I multiply the other side by that same number, have I maintained that idea of equality? Okay, are you ready?
No.
Okay, Nice. So, let's try this problem. Okay, so I have 3 over x plus 6 over x plus 3 is equal to 2. Okay, what will the least common denominator be?
X squared plus 3x.
Okay, so if I multiply everything by x times x plus 3, this whole thing, what are we gonna get? So I have, let's see, x squared, I have x squared plus 3x, right, times 3. It's going to be what, 3x squared plus 9x? And what am I going to have here?
6x squared plus 18x.
Is equal to,
2x squared plus 6x.
Wait, but what
Yeah,
about
you
the
got it.
denominators? Don't you have to leave them in? Oh, wait, no, they're being divided. Never mind, that was weird.
okay? Wait a minute, actually I have to think this through. What did I do? No, you know what? I did this wrong.
Yeah.
I did this wrong, sorry. Scratch that.
Wait, oh, now I'm.
Sorry.
Um,
So I'm
I don't
multiplying this, I know, I'm sorry. 3x